Okay, the class starts. As I told you today, I want you to work on a problem. I will describe the problem. Probably have anticipated yesterday, but I want to explain and what's the problem and why. First, let me ask if there are questions, comments of any kind about what we are doing, about the second assignment, about anything, about the shared memory, anything. Questions? One of you, don't remember the name, asked me, posed a question yesterday about the virtual machine. I replied that I'm not so expert of running a virtual machine and exploiting it, because yes, I use, but not so widely. And the problem was related to how, yes, you're running Linux on a virtual machine and connecting the virtual machine with the internet and with the cloud machine in particular. The question was about the IP address of the virtual machine. I'm not so expert, so I tried to reply. In general, if you're running Linux in a virtual machine, it should have a different IP from the host operating system. So the host operating system and the virtual machine should have different IP address. It depends on the configuration of the virtual machine, since normally the IP address is given your machine by a DHCP server, so it's a dynamic IP. Normally, and in DHCP is on the modem that you use to connect to the internet or a router in the local area. And normally, the virtual machine has a wrapper of the network adapter, as to say the board for connecting to the internet, simulating a new low-level address, the so-called MAC, the MAC address. So they receive two different IP addresses, and they should, because there are two operating systems running simultaneously, and they are different. And it's also the way in which the two machines communicate each other. But that's all I know. So, but in any case, consider the fact that, well, so this may be a possible solution. You have to solve. Probably Professor Recchiuto is has more knowledge about details in virtual machine and in particular in networking. So we can ask him, or you can directly ask him. Talking about the virtual machine on cloud, I have also to say one thing. Yesterday we did a simple example in which we have the socket server running on cloud. And if you remember, it's important to ask Azure to keep constant the IP address of the public IP address of the machine in cloud. So you can use freely connecting to a server located on that machine. And in the network, on the left hand, I don't want to open again the Azure panel. If you, on the left, there are several items you can click on. For example, networking, and you can configure the network. You can configure the network saying which are the protocols that are that can be used. And in general, I suggest you, well, it's necessary to keep open the TCP IP. TCP should be open. Also UDP. I don't know if in the final assignment you will be asked to use also UDP, but in any case, both protocols are open. You can we can state several rules for security and safety. You can keep open some ports or closed as you do in your machine with the firewall. And if you need help, ask me. I can reply and can help you in that. The one thing I want to point out that it's not the example we have run yesterday with the socket server on the virtual machine in Azure cannot be reversed. So it's usually, it's not impossible, but usually you cannot run the socket server on your computer at home and running the client in the virtual machine, so reversing. Well, in general, theoretically it is possible, but sometimes it is very difficult to do that, because to do that you need a public address on your computer. So generally it is not given. So if you're connected to the internet using provider, the provider usually gives you an IP address, and the IP address is on your router or the ADSL or the fiber modem. And then you have a local network with local addresses inside. So the address of your PC is not public. It's a private address that can be reached and is known only in the local network. There are several possibilities. So the problems are, there are two problems. The fact that the public IP is on your router and your provider gives you the public IP, and usually it changes, so it is not static. You can know which is the number, and in some cases you can ask your provider to keep static. So do not change when you switch off and switch on the modem. And the other problem is how to reach your computers. To do that, you must activate the network address translation, so that net on the router, that's not obvious. It is possible, so you can decide. So, but you need to do two steps. One is to make public or static or known from the internet side the IP address of your router that connects you to the internet, and then you have to program your router or to go into the web interface and to activate the network address translation, so that your PC responds to the IP address of the router. And in addition, you have to open the ports for connection. And sometimes it's not possible because it depends on the policy of your provider. Some providers ban some protocols, so not all ports are available in general. So even if it is possible to reverse the examples, to make your PC a public socket server, in general it's difficult and tricky, and the policy for doing that is not uniform. This is the reason I asked to activate the virtual machine, so that all virtual machines on Azure have public IP and can be used freely, and you will be asked to connect your virtual machine on Azure with some other virtual machine of some other colleagues of yours for the exam. And this will be absolutely possible. Trying to do that with your personal computer at home is very tricky, and so it's outside of the aim of our course. And in any case, the learning to use the virtual machine on cloud is a good subject, good practice, good expertise that I want to do. So I hope that been clear. Don't try to reverse the position of the server, and keep the server where the IP is public and ports are open, always on cloud. Otherwise, you lose your time, and it's very tricky. This is not really strictly related to the question I told you by one of you yesterday regarding the IP address on the virtual machine on the using the hosting. I don't know if hosted by a Mac or Windows, but this probably is another problem. So we can go on with questions regarding that. I hope I've been clear and not it didn't make additional confusion to for some of you. I want to make all things as simple as possible for your exercises. Okay, go on in solving the first assignment and start to do the second assignment. I confirm that the deadline for the second assignment will be at the end of the next week. I will open today the repository in our web for the second assignment. Well, I want you to work all together. You are 20, so I will generate one only breakout room. Hope that it works. Let me explain for what. It's just a theoretical work. The output of the work I'm asking you to carry out is just a scratch or a short report written in freely, and in this case, not necessary, not compulsory. In any case, I will open also repository for uploading your personal solution or group solution, doesn't matter. That will not be evaluated, so no evaluation. Please don't be timid in any case. I don't want to scare you. The reason is that it is a good feedback for me, and giving you also the possibility of writing a short report is just to help you to be smart in doing that, because in the exam, one of the questions will be exactly of this kind. Let me, well, at the end of the work, we will comment it. Let me explain what I want you to solve. If we go back to the first week in our web, let me see. Okay, it was week 1. Week 1. Okay, this is week 1. You see the screen? Can you see? Surely.
Yes, we can see the screen.
Yes, you see. So the material for Tuesday's class, this document, I have this document in original, so I can use it is here, so good. So we go back to the origin of when we started. Robot programming introduction, you see the document, I think. Yes, I think so. this was just an introduction and discussion of the, well, theoretical and but more general terms. There we found you remember the example of the mobile robot. I know that Professor Recchiuto is talking about this example because it's a simple but real example of the autonomous machine, and so a real robot with the basic elements. We have given also some scratches about that, talking about the different components of a system like that, for giving reason why we are talking about concurrency. Concurrency means several processes in our terminology, several components, several system components acting separately, autonomously, in pseudo-parallelism. So we call them tasks in general. That's the more generic terminology. And the one-to-one correspondence between task and POSIX terminology is the process family. Processes are tasks. So we have several, and then we had a problem. If we have several tasks, like in the first slide here, these are tasks. Remember, my child is drawing. Path planning is something that executes separately. Collision avoidance, localization. You remember the laser scanner. But not only the laser scanner, but any other system for localization of the robot, for example, GPS, anything. Here, usually the lowest level algorithms are depicted in the lowest part of the figure, but it's not necessary. And we write on top the more abstract user interface. Path planning is artificial intelligence, maybe an artificial intelligence or control system model that generates the trajectory. And here are the parts that are connected directly to the motors, like we do in the second assignment, in which the motor is just switched on and off for the hoist. But in general, those processes controls strictly, in a strict loop, with the timing, very strict timing, the rotation of motors, and in taking the measurement of the rotation and so on. So localization, and it's the computing the position in space, in the Cartesian space of the robot, taking into account all the information taken from the laser scanner, from GPS, or any other device for localization, and the so-called the odometry that the term odometry will be clear in the second semester in the mobile robot course, in which odometry is a way of reconstructing the position of the robot, just measuring how much the wheels have been moved, the angular position of the moved and of the steerings and everything. So combining all this, there is localization. So the term is tasks. So a robot, in general, a smart automation system, is a set of tasks. Tasks are independent processes, and processes must communicate. That's simply conclusion. So I'm trying to rewind the tape and starting again from the beginning. So we have the need of making tasks communicate. These are examples, but there are more than examples. There are communication models or communication policies. Here, the formalism for describing that is taken from UML language or standard, but can be understood in any case. So there are two basic methods, logically, not more than two. One is sending messages, and the other is sharing memory, common memory in general. Probably you're hearing my cat. It's in the morning. He asks for help. Then both models, so messages or access to shared memory. Silent. Okay. There are types of so the who initiates the communication can be of four types. Push and pull are the in general two philosophies. In the push method, you send data and you assume that the consumer receives. Pull is a system, theoretical system, in which data are transferred upon request. So if you don't request data, the transmission doesn't come. And publish subscribe is very important, and you already know in ROS that is a central method. Publish subscribe, and is typical and really common in systems like this one, in which communication can be must not be fixed. So communication channels. So I mean the fact that you may introduce a new element and run a new process, and it starts producing data or asking for new data, but sometimes it can shut off or ask for new data that never asked before. So the need of having dynamic communication channels. You know what is publish subscribe, and publish to a Blackboard is similar, is a version of publish subscribe. Here is mainly based on messages. It is published to Blackboard is mainly based on shared memory. But the idea is similar. So there is some generator of information. So the first step is that C subscribes to P and says, okay, from now on, I want this kind of data. Public subscription includes the data. Let me quote the name. That is a sort of, you can say, a tag or semantics. What I mean with that, the fact that P can be a generator of different kind of information, not only one. So subscription is to all data generated by P of some family. Can be, I want to subscribe only to actual position, want to subscribe only to emergencies or something like that. This is my wall clock. So that the subscription phase, and there is also the unsubscribe. So sometimes C can say, I don't want to have data of that type coming from P. And another important, so it's a very complex, is a rich model of transmission. The idea is that all data produced by P are sequenced. So you are in queued. You have a queue of all data produced. They can be at strict timing or randomly generated in time, but doesn't matter. So the idea is that all data generated are consumed. The same data are consumed by all subscribers. So the idea is that if there is another subscriber, if C consumes this and this, C, and C1 is standing still, C1 will also receive T1 and T2 with its own timing. So the idea is that not only the first, the quickest consumer consumes the data of this kind. Is the model is that of subscription to a review, to a journal. All subscribers receive a copy, and not only the first one is lucky and uses the journal or the newspaper is subscribed to. Published to Blackboard, similar, but the fact that there is a common, so in a sense is a simplification of the previous one, since all data are published. And no queue, just the last item, typical for example, for a laser scanner. You're not interested probably in the history of all data given by the proximity sensor, just the last one. So they are posted here. So new data from P override previously sent data. But in general, all consumers can consume that datum. So it's not erased by the first one who. So if there is a C1 request data, and data is persistent, is changed only when P generates a new datum. So these are the models. In general, all these models, so using the methodology, these are the basic framework. Shared or sent. Shared or sent. The implementation of the shared or sent is based on this 4 systems. In general, also in software engineering, distributed systems, not only in real-time systems. These are the methods used to make agents or tasks communicate each other in the network, in the internet, in the same machine, and so on. What is the stop share? And I say and explain which is the work that I'm asking you to carry out and to do today. Work together, but as I told you in advance, but someone may be connected after, I will also open a repository to upload your scratch, your small report, just one page, or I mean, any method you want, any language, any in plain form, using pencil or the keyboard, what you want, just to have a feedback, because this is something related to one or more than one questions I will pose in the exam. What's the subject of this? I want you to design an implementation of publish, subscribe, all the four model that we have presented in that method using POSIX primitives. So considering to have processes, how you could implement a direct connection, messages, push and pull messages, how you can implement publish into a Blackboard with subscription, and how you can implement a method for having a publish subscribe. For a publish subscribe, let me sketch the structure because it's the most complex. I will let me do this way. So just model things like this. Two processes, how to communicate with the simple messages, both in push and pull. If there are two processes, how can they communicate with the shared memory? Maybe it's simple because we talked yesterday how to do that. More complex. Producer, consumer 1, consumer 2, and consumer N. You have to say how to subscribe, and how to get information. Suppose that P is the classical loop that generates data. P generates for example, data of two types. T1 and T2. Subscription is subscribe to P for T1 or T2 or both. So how to make this subscription? So in practice, in POSIX, what you need to do that? You need pipes, you need signals, you need a named pipe or what? Or a shared memory. And how P sends data to the subscribers, and last, of course, simple, the unsubscribe. How to do that? How to model? It's just idea of writing which are the primitives, which are the IPC needed for doing that, and data structures in more details as possible. The last one is the same with the. Oh, also here we have how to do that. The P and C1 and C2 with the shared memory. I think it's simpler, but it needs to be modeled. I suggest that, well, the most complex problem in POSIX is this one: publish, subscribe. But nevertheless, it has to be solved because we need ROS, we need to implement this in our robot. So we must solve. The first two models probably are very simple, but what I'm expecting a short report written in any form that details and describes in more detail, so it is clear how to build a system, an architecture for solving this problem. Also, the other problems are much simpler because there is one-to-one correspondence between the model and POSIX primitives. Here, there is no direct POSIX primitive to do that. How is maybe, for example, 3 pipes, one for each process, unnamed pipe, maybe named pipes, one for each process. What's the system? We need synchronization. Well, what you must decide you need synchronization. You need non-determinism. So C1, C2, and Cn or P need also to select the pipes for during communication. Well, that's the problem I want you to solve. It's a really important problem, so important that we will also discuss together. But I want you to work first on this, and next week we will solve this, but I want to solve basing on your suggestion. I want you to be involved, since it's the only way I can understand or can try to understand how much you are inside the subject and how much you have learned from this. This is the reason why I want you to upload your solution with absolutely no fear that it will be bad judgment for you. Absolutely not. I cannot set up a repository for anonymous uploading. Unfortunately, there's no Aula web methods for doing that, but I assure you that will be just a feedback. So this is the problem. I will publish this in Aula web immediately, and I will ask you to work for 40 minutes on that altogether. So the different steps are just saving this. Well, I will do. Yes, let me save while you see that. Not here. No, sorry. Okay. Saved. To be sure, I will also save in this form. Okay. Now we'll upload, and in any case, I will make the break. So questions about, I think it's a more complicated problem that I've explained, but it's really, really important. This is subject for just for conclusion. So the first lesson and the last lessons will join together, because this was the aim of the course. And consider that the fact that it will be also part of the exam. So that's the reason why I want you to work on this. Questions? So in any case, you start now. I will upload immediately in our web, and you will see. No. Okay, so I have to share. Okay. Hello. You came back. I hope that you have been working and you have done a good work. I think it's really important to, so I push you to finalize the discussion you had. And I have opened in the Aula web also the repository with free assignment. And I'm asking you to upload solutions or any kind of document. I need a feedback from you. And based on what you upload, I will finalize the next class and next week. And I have also some code examples for that in the last year's students did. So I think it's a good job. Okay, thank you. Questions regarding
Me.
Yeah, yes, please.
What happens if a consumer sends a signal, and so a producer is handling this signal? Meanwhile, another consumer sends another signal.
Well, signals are enqueued. So maybe yesterday you have seen also when the common U limit with the number, and so you could know how many signals are managed by the system. So all signals received, if they are not masked,
Okay.
so when you can specify the mask, signals are received. And so, and immediately the signal handler is works after a signal is received, but other signals keep pending. So if they are not masked, many signals can, just like interrupts. They work exactly with in the same way hardware interrupt do.
Okay, so there are not nested.
Not lost.
Okay, thank you.
So it's a possibility of using that. Yes. So okay, I think that the class is over. Thank you very much. All documents are uploaded, have been uploaded. You know that in any moment you can call me using the messaging system, using Skype in particular. In a short time, I had to discuss with some other students for the first assignment. We have an appointment using Skype. And so if you need also for questions in any case, and in any case on Saturday, there is the normal question and answer meeting if some of you is interested. Okay, thank you very much. See you next week. Have a good job, study, work, and stay away from the virus. Okay, bye-bye. Thank you.
Thank you, Professor.